Welcome, developers. Today, we're unlocking a massive productivity multiplier in Claude Code, Git Worktrees. We will learn how to run multiple AI coding agents in parallel, managing different versions of your code across isolated folders without ever needing to stash changes or switch branches. Let's get started. Let's start by defining what Git Worktrees actually are. What is it? A Git Worktree is a feature that lets you check out multiple branches of the same repository into completely separate directories at the same time. The basics: instead of cloning your entire repository twice, you maintain one underlying Git database, but get multiple working folders. Why is this revolutionary for AI development? Because context switching is a massive bottleneck. If an AI is halfway through building a complex feature and you need it to urgently fix a production bug, stashing files and swapping branches destroys the flow and pollutes the context window. How does Claude solve this? It leverages Worktrees to give each task its own physical directory. In our deep dive, we realized that because Worktrees share the same .git database, they're incredibly lightweight. You can run multiple agents pushing commits concurrently without corrupting your repository. Take a look at this flowchart representing the Worktree architecture. At the top, we have a single, shared .git database. Instead of just one working tree, it fans out into 3 distinct physical directories on your hard drive. You have your main directory on the main branch, Worktree 1 dedicated to a bug fix, and Worktree 2 dedicated to a new feature. All 3 exist simultaneously, allowing you to seamlessly tab between them. To appreciate Worktrees, we must understand the traditional branching bottleneck. What is it? It's the sequential development model where only one branch is active in your folder at any given time. The basics involve running git checkout to swap the files currently visible on your screen. Why does this completely fail in the age of AI? Because if you instruct 2 Claude Code agents to work on different tasks in the same folder, they will step on each other's toes. How does it manifest? Agent A might delete a file as part of a refactor, while Agent B is simultaneously trying to add a function to it, causing a crash. In our deep dive, we recognize that agentic workflows demand absolute environmental isolation. An LLM builds a cognitive map of your files. If another process silently mutates the environment, the LLM's next tool call will hallucinate and fail. Isolation is non-negotiable. This sequence diagram illustrates the disaster of using a single directory for parallel AI tasks. The developer asks Agent A to build a feature, and it starts editing app.js. Meanwhile, the developer asks Agent B to fix a bug in the same folder. Agent B aggressively overwrites app.js. When Agent A attempts its next step, it encounters a catastrophic crash because the file state mutated unexpectedly. This is why we must adopt Worktrees. Now, let's learn how to actually launch these environments. What are we doing? We are using native CLI flags and Claude Code to automate Git Worktree generation. The basics are simple. You append the Worktree or W flag when starting Claude. Why is this built in? Because manually executing standard Git Worktree commands involves tedious boilerplate. Claude removes the friction entirely. How do you do it? Look at our sample code. You simply type Claude W featureauth in your terminal. Claude Code immediately creates a new physical directory named featureauth, provisions a new Git branch with the same name, and boots up an isolated AI session right inside it. In our deep dive, we see that Claude actively manages this lifecycle. If you close your terminal, that feature code remains safely parked in its isolated folder and branch, completely segregated from your main development work. Follow the execution path in this flowchart. You issue the command Claude W featureauth on the left. The engine forks into 2 operations. It creates a new Git branch, and it provisions a new physical folder on your drive. These 2 elements converge to host the isolated AI session on the right. You now have a sandboxed playground that is perfectly safe for autonomous code generation. We can take this further with subagents and Worktree isolation. What does this mean? It means configuring specialized subagents to automatically spin up their own worktrees when the main agent delegates a task to them. The basics: you define a subagent in your .claude/agents folder and add isolation, Worktree, to its YAML front matter. Why is this a massive safety upgrade? If you ask a subagent to perform heavy, experimental refactoring, you need a blast radius that protects your main directory from catastrophic hallucinations. How do you do it? Just add that single line of YAML. For our deep dive, the internal mechanics are fascinating. When the subagent spawns, Claude fires a Worktree create event. The agent performs its coding in a sandboxed sibling directory. If the experiment fails or the agent makes no permanent changes, Claude is smart enough to automatically clean up and delete the worktree. This state diagram maps the lifecycle of an isolated subagent. The main agent decides to delegate a task that requires risky refactoring. Because of our configuration, it transitions to spawn worktree. Inside this sandbox, the agent runs code experiments. If the tests fail, it automatically cleans up the directory and reports back. If the tests pass, it leaves the worktree intact and returns the success and branch information to the main agent. When creating multiple directories, we must master file system management using .worktree include. What is this? It's a special file used to ensure vital local configurations are copied to your new worktrees. The basics: Git worktrees brilliantly replicate your repository, but by design, they do not copy files that are ignored by Git, like your .env secret files. Why is this a huge problem? If your AI agent tries to spin up a local development server in the new worktree to test its code, the server will crash because the database passwords are missing. How do we fix this? Create a .worktree include file at your project root and simply list .env. In our deep dive, this file acts as a manifest. When Claude Code provisions the new folder, it explicitly injects those ignored files into the sandbox. This guarantees the AI's environment is instantly runnable, testable, and fully authenticated. This architecture diagram visualizes the provisioning process. From the project root, the new feature worktree is generated using the shared .git database. However, look at the dotted line from the .worktree include list. As the worktree is created, Claude explicitly copies the local secrets, like your .env file, across the boundary and injects them into the yellow worktree node, ensuring the new environment is fully functional. Let's examine a highly impactful real-time use case: parallel feature development. The scenario: you need to fix a critical database bug, but you also want a background AI agent to completely redesign a massive UI component. The problem: if you use one directory, checking out the bug fix branch will stash the UI files, completely breaking the background agent's environment. The execution: you open two terminals. In Terminal 1, you run Claude w fixdb bug. In Terminal 2, you run Claude w redesign UI. The outcome: you now have two separate physical directories. Both Claude instances run completely independently. The immense value delivered here is extreme scale. The background agent autonomously updates the UI, runs its own tests, and commits its code in folder A, while you and the local agent solve the database crisis in folder B. 0 Git conflicts. 0 stashing. 2x development velocity. This journey map clearly illustrates the parallel processing power you now wield. In Terminal 1, the user launches the database fix worktree, and Claude works sequentially to diagnose, fix, and commit the code. Simultaneously, in Terminal 2, a separate instance launches the redesign worktree. The Claude agent independently analyzes UI components and commits its branch. Two distinct streams of productivity happening at the exact same time. We have built our features in parallel, but now we must execute merging and consolidating. What is this? It's the process of taking the isolated code from multiple work trees and unifying it into your main project branch. The basics: because every worktree is just a standard Git branch under the hood, you simply push the commits from each folder. Why do this? Because development happens in isolation for safety, but deployment requires integration. How do you do it effortlessly? Just ask Claude Code, merge the fixdb and redesign UI branches into main. For our deep dive, Claude implements a highly secure integration pattern. Instead of blindly merging into main, it provisions a temporary integration branch like main merge. It pulls the parallel commits together, autonomously resolves any CSS or logic merge conflicts, and runs local tests to ensure the consolidated build is stable before you push it to production. Look at this consolidation flowchart. The isolated commits from the fixdb worktree and the redesign UI worktree flow directly into the orange integration branch node. Here, Claude acts as the orchestrator, resolving any merge conflicts. The code then flows through the test suite. Once the tests pass, it proceeds safely to the green main deployment branch. Isolation during creation, secure consolidation before deployment. Let's wrap up with best practices for managing your environments. First, treat work trees as ephemeral. They are temporary workspaces. Once your feature is successfully merged, delete the directory to keep your file system light and clean. Second, verify your context. Make sure your Claude.md and .worktree include files are perfect in the root repository, so every new agent inherits the exact right instructions and secrets. Third, test before pushing. Always run your local test suite in the consolidated integration branch before pushing code to production. Finally, run git worktree prune occasionally to clean up any internal Git references to folders you deleted. Mastering Worktrees shifts you from sequential coding to massive parallel execution. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. This final state diagram illustrates the perfect cleanup lifecycle. You start with an active worktree. Once your pull request is approved and merged, you transition to the merge complete state. From there, you perform the physical cleanup by deleting the folder. Finally, you transition to prune git by running the command to clear the references, resulting in a pristine, clean file system ready for your next massive project.